Thank you very much. Thank you very much for this invitation. My name is Jaume Baixeries. I'm a computer scientist, so I'm not one of yours. I'm on the other side. I work in the Department of Computer Science in the Politècnica University of Catalunya in Barcelona, Catalunya. So in this talk, I will try to do one thing, which is try to convince you that quantitative linguistics may be an interesting approach, may be helpful for humanities research. So my presentation will be divided into two parts. In the first part, I will present quantitative linguistics and also the work that we do in our lab, also basically to help you understand what quantitative linguistics is about. I will try to convince you that quantitative linguistics can be of interest to humanities. And if I did not succeed in convincing you in the first part, in the second part of my presentation, I will show you how quantitative linguistics can be applied to one specific subject, which is that of plagiarism. So let's talk about quantitative linguistics. This is a tree that shows the main subjects which are in artificial intelligence. Obviously, this tree is far from being complete, but just to give you an idea of where quantitative linguistics is located. Quantitative linguistics is a sub-branch of natural language processing, which is one of the main branch of artificial intelligence. So quantitative linguistics examines patterns, finds patterns, laws that apply to all languages. One thing which needs to be clear is that quantitative linguistics treats human language as a whole. It doesn't treat particular languages, but it considers human language to be a communication system of its own, and it studies this communication system. We used to find these patterns and laws using mathematical and physical and laws that also appear in physics. So a more detailed definition of quantitative linguistics, which can be a little bit harsh on classical linguistics, is that of Gabriel Allman. He said that quantitative linguistics searches for models of phenomena and tests these models. That means we observe things in language, we propose a mathematical model, and we test this model. And this is something that is done in physics, in engineering, in every branch of science. And he opposes this view to the classical view of what he calls qualitative linguistics, that is classical linguistics, in which, according to Gabriel Allman, you adhere to one school and, for instance, you decide that you belong to the generative grammar linguist, branch of linguistics, you stay there and you fight against other branches or other schools. I know it's a little bit harsh because probably that's not exactly the truth, but it's just the opposition of two points of view of the same subject, language. We treat it as a physical phenomenon, and which is different from the classical view in classical linguistics. So quantitative linguistics is a discipline of its own. The basic goals of quantitative linguistics are finding, identifying laws and universals that happen in all languages. Probably some of you are already familiar with the Zipf's law. We will come maybe back to these laws later. We studied those things, but we assume that those laws and universals apply to all languages of the world, and then try to empirically test whether they hold or not in languages, as we will see soon. Quantitative linguistics also measures the complexity of languages. This is how much effort a speaker or a listener of a language has to do in order to understand, to produce and understand the sentences. It also studies how languages change in general terms over time. For instance, whether agglutinative languages tend to become inflectional over time. I'm not saying that this is true. I'm saying that this is one of the branches of the things that are studied in quantitative linguistics. We also study language acquisition. This is how children and foreign learners, L2 learners, learn a language. We will come back to that shortly. There is also a branch of quantitative linguistics, which is that of stilometry, which proposes different measures of stilometry in order to be able to map texts to authors. And in the second part of my presentation, we will go deeper into that. So from our point of view, quantitative linguistics is of interest to humanities because quantitative linguistics explains human language as a whole. It explains everything. It tries to explain everything. Its origins, its evolution, how it's learned, how it's used, and how it's evolving. And since language is the main cultural vehicle in, well, as long as I know, in humankind, then we think that the study of quantitative linguistics can be of interest to humanities. However, I will explain further and I will give you some more examples to prove you that this is true. So, and also there is an interesting thing in quantitative linguistics is that opposed to some other results in machine learning, etc., in artificial in general terms, in artificial intelligence in general terms, the results in quantitative linguistics may be easier to understand because the machinery that we employ sometimes is not as sophisticated as in other methods. But it's not always true, but it's somehow true. So let me introduce you briefly our laboratory, which is called in Catalan Lingüística Quantitativa Matemàtica I Computacional. I don't need to translate this name. We are 9 members. We have many visitors. Mostly, we are computer scientists, and that may be a little bit awkward because one may think, okay, what are computer scientists doing in linguistics? Well, we have linguists, we have physicists, and we have mathematicians. Honestly, I'm honest, we have a linguist and we have a physicist, that's true. They happen to be the same person, so mostly we are computer scientists. The list of items that are of our interest maps almost the list that I gave previously, and we will go deep into this list right away. So some of the things that we study is the testing empirically the existence of language universal in different languages, mostly in Catalan. What does it mean? We assume as a hypothesis that, for instance, the zip law of brevity, for instance, holds, and we examine large data sets containing text in Catalan, and we verify empirically that these laws hold also in Catalan or in other languages, but mostly in Catalan, in English or Spanish. We also study optimization, efficiency, and complexity in human language. As I said, this is the amount of effort that a speaker or a listener has to do in order to understand or to produce sentences in a language. We also study how children acquire language. We have a couple of papers which explain how children acquire polysemy when they learn a language. What we did was to take conversations of adults. Here we have 3 adults, father, investigator, and mother, with children. So they start speaking to them when they are 10 months old, 20 months old, 30 months old, etc., etc. And we test the average polysemy of the words that are used by each group. Polysemy, we assume that polysemy is the number of different meanings that a single word can have. For instance, bank may mean a place to sit, or also a financial institution, for instance. So what we see in this graphic, which appears in the paper in 2018, is that children, when they learn a language, they use words which contain low polysemous words. And then during the period of between 10 and 30 months of age, their average polysemy reaches that of adults. The interesting fact here is that psychologists, linguists, etc., have already observed that children tend to speak well. It means tend to make sentences that make sense, that are grammatically correct, etc., when they are in this period of time between 30 and 40 months old. So our results matches the observations which were performed before by psychologists and linguists. Obviously, here the explanation or the interpretation of this result is still open. Don't they use polysemy because it's difficult for them, because they are not exposed to? Well, they are exposed to, because if we look at the average polysemy of adults at the same age, it remains constant along the time. So parents and adults use the same amount of polysemous words, regardless of the age of the child. Yet children, they don't have the same capacity to use those words at the beginning. Do they start to speak well because they have been able to acquire this amount of polysemous words? Again, this question remains open. We also study communication systems beyond human language. That is, how animals or chemical compounds communicate. Because again, quantitative linguistics takes language as a communication system. Our two members of our group have published a textbook in quantitative linguistics in Spanish, which has been translated into Italian and will be soon translated into Romanian. And well, that's it. That's the first part of my talk. So I don't know if I convinced you much if quantitative linguistics can be of interest to you or not. I hope I somehow did. But now I will show you one application of one branch of quantitative linguistics, which is stilometry. And stilometry facing one problem which is currently present, which is that of plagiarism. Plagiarism is the guy behind the door, the ugly one. And well, plagiarism abounds. Here we are all lecturers and students, and if we are all honest, we will agree that this is a real problem. So now I will show you some weird cases of plagiarisms. I think that I don't need to convince you that plagiarism is a problem, but I will give you, nevertheless, some examples. I will ask whether AI detectors can detect AI texts. And then I will show you how quantitative linguistics handles this problem with stilometry. So this, to show you just one single example of how difficult it may be to distinguish between real things and not so real things, I have this funny example. Please, can you play the video?
はい、こんにちは。私はタムです。テキサスから来ました。英語を勉強しています。やった。I love the Japanese people, obviously. Shooting Last Samurai was extraordinary. They also make incredible timepieces. Just the sparkle. Misa Sparkle. Shut up! Okay, do I need to go and do an Australian accent for the Australian market? We did Japan, right? We're good on that motion?
Okay, thank you. Well, this is just one funny example. Obviously, this video is fake, but it's fake because the oops. Oh, thank you so much. It's fake because I told you that it was fake because it comes from an X account which is called Deep Tom Cruise, which suggests that probably the video is fake. It displays Tom Cruise speaking in Japanese, etc. However, the video looks very, very true. I mean, if Tom Cruise was not doing those weird things and talking about those weird things, probably it would be something that we could think that it could be true. So this is just to show you that we are surrounded by things, and now it's very difficult to distinguish real from fake things. So from now on, I will just stick to written text. I will leave behind video, images, and so on. So some extreme weird cases of plagiarism is, for instance, the possibility, you already know that Amazon offers the possibility to self-publish books, which has a good side, which is that it democratizes the publishing of books. Also, it has some bad sides, which is the fact that everything can be published. And in fact, they are flooded by texts which are AI generated. Another weird case of plagiarism is that of an author, which well, one of his friends called him and said, okay, I saw your paper in this journal, which has been accepted, congratulations. And that person was shocked because that paper, well, he knew nothing about it, but it was authored by him. And in fact, it had been accepted in a conference. And somebody used his name to fake a paper, submit to a journal, the journal accepted it, and it was on the system. So the paper was not written by him, it was clearly AI generated. Another weird example of plagiarism is that of Deloitte, which decided that instead of finding help in AI systems, decided that AI systems should do all the work. So they just issued a work which contained simply false information. This document passed through because on the surface it looked legitimate, and that's the problem with AI, that everything that produces, it looks legitimate, it looks human, but then if you analyze it, it's not human, and that's the problem. So one legitimate question would be, can AI detect AI? I did a small experiment on my own. So what I did was to take an article which was published in a website. This article is called The Alabama Solution, which is a review of a documentary with the same name. And I prompt ChatGPT the following. I have an article in English. Can you write an article mimicking the same style and the same subject? I need it to be of the same length. So ChatGPT produced this, well, that's the header of both papers. So you can see if you read both headers, both look legitimate. They look, well, at least to me, but I'm not a native speaker of English, so, but they look legitimate to me. The only problem is that the AI-generated text obviously contained some hallucinations, as they called the errors that appear on AI systems. So for instance, the lost one is not the name of any film. I checked on the Internet Movie Database. There were some lost one films, but they were films, not documentaries. Nia Caldwell is not a film director. At least it doesn't appear in IMDb. And sadly enough, Greenwood Youth Rehabilitation Center seems not to exist. But in order to verify it, I asked ChatGPT, which produced this text, to check for this place. And the same ChatGPT answered that it was not able to find credible evidence that this youth rehabilitation center existed. So one may think that, okay, if a text contains hallucinations, probably it's very easy to find out that it's not a legitimate text. So what I did is to check those 6 AI systems, AI detectors, whether they could tell me if this text was legitimate or not. GPT-0 and Copilix performed pretty well, but the remaining 4 did not. So I did another text using asking ChatGPT to produce a text similar to that of one article written by Ampar Moliner. Ampar Moliner is a Catalan writer, journalist, author. She also appears on TV. She has a very specific style, so we thought that because of that, it would be easily copied. It's like what we saw previously. Tom Cruise has a very specific set of features which make him very, well, unique, let's say. He's very histrionic, so it's quite easy, I guess, to copy him. That's the case of Ampar Moliner. So in this case, ChatGPT performed really bad, Copilix really bad as well, and Just Dan, which previously performed really bad, now performed really well. So I'm not claiming that those AI detectors are not good enough because I did 2 experiments. I have to say that those 2 experiments were not cherry-picked. We just did those 2 experiments and we had contradictory results. However, there is a paper which is published in Spanish in which what they do is they create 3 sets of text in Spanish. Human text, text created by AI systems, by large language models, and mixed text, which is something that we will see now that it also exists. And they check the performance of 3 detectors against text generated by ChatGPT, Gemini, and Grok. What they said is that statistically, texts which were mixed were not well detected by those 3 systems. And the conclusion is very clear. You take a huge risk if you rely solely on those detectors. So, and yet we need to distinguish between texts which are generated by humans and texts which are generated by large language models. For ethical reasons, obviously, also for legal reasons, and also for a practical reason, which is that we have to prevent to train those large language models with texts which have been created by themselves. Those systems need to be fed with materials of human origin. So I will show you now very shortly in 4 papers short how stellometry in quantitative linguistics may handle this problem well. This paper is very interesting because what they do is they take text from Ernest Hemingway and Mary Shelley and they ask ChatGPT to generate similar text. They have 3 prompts. They say, can you generate a text like this one? They also say, can you generate a text like this one mimicking the style of the author? And finally they say, can you generate a text like this one mimicking the style of the author and also talking about the same theme? So they compare the text and they want to distinguish between text generated by humans, I mean the original text, and those generated by LLM systems. The conclusion is that LLM systems can imitate very well the style of a writer, just as we saw previously in the case of Tom Cruise. I mean, it was Tom Cruise, but it was not, except for the fact that it was not. So they do that. They imitate the style very well, but if you perform an in-depth analysis, then you catch them. In this paper, what they do, they analyze academic papers. They claim that a large language model overused some words in some different periods of time. Let's say that in 2023, some words were overused by large language models. In 2024, some other words. In 2025, some other words. So what they observed is that words which were overused in the past are not overused now in academic papers. And words which are currently favored by large language models are now increased its presence in academic papers, which according to the authors seems to suggest that authors, they take information from large language models and they edit the papers. There are two more papers which are relevant because they classify text generated by humans and text generated by AI models. This paper here and this paper here, using different stilometric measures and sophisticated machine learning methods, they are able to distinguish things. So it means that quantitative linguistics seems to be very good in distinguishing between text created by humans in a consistent way and text created by large language model. We don't have those things that in some cases we do it well and in other cases we don't do it well. The results are very consistent and very determinant. Quantitative linguistics has a set of methods that seem to work in this case. The only two problems that may be attributed to those methods that we've seen before is that they may be difficult to train because some of the methods need to be trained and it costs, and also that the results may be a little bit difficult to interpret. I mean, the results, the outcome of these systems is clear. This is a human created text, this is not. However, to understand the reason why it classifies this text as human or as non-human may be a little bit difficult to understand because of the sophistication of the systems. So from our laboratory, we have proposed a new measure, which is that of semanticity. Semanticity is the number of different words that the semanticity of a word, for instance, the semanticity of the word house, with a distance d, is the number of different words which are found in text at a distance from this word. It may be a simple measure. It captures some a little bit of syntax, which is this distance, and a little bit of semantics, which is the different number of words this word is related to. But we have used successfully to distinguish content words and function words in Catalan. And we are using currently this measure to distinguish human and LLM generated text. The good thing about this measure is that it's very simple, it's very easy to compute, it's very easy to interpret. So if we have successful results, the results will be very easily interpretable. So the conclusions. We cannot ignore the presence of AI, and we cannot ignore the fact that we have to deal with the burden of having to distinguish human-created text and AI-created text that exist, that will exist, and that will be forever. There is no magical rule. I mean, maybe those methods which are successful now will not be successful in the future because large language models in particular are becoming every time better and better. So what we need to do is to improve our methodology when those methods improve. But the thing that I want to stress here is that we provide models. Models say things, but they need to be interpreted. Meaning needs to be given to those models. We give mathematical equations, we give statistical methods, but still we need to interpret, we need to give meaning to those models. And I think that this is the job of humanity researchers, to understand what we do and interpret it and give it back to society so that it can help to explain what's going on in the world. So if I have to conclude, and the general idea of my talk is that computer scientists, which is this robot there in the right-hand side, and humanity researchers, which is this Greek philosopher, we need to work together and we need to be friends. 감사합니다.